Welcome to the first video in our series on matrices. In this video, we explore what a matrix is, understand basic matrix types, square, rectangular, zero, and identity matrices, and discuss some real-world applications. Whether you're new to linear algebra or looking for a solid refresher, this video is the perfect place to start. Check out my book, Foundations of Matrix Magic, to dive deeper into matrices and linear algebra concepts. A matrix is a rectangular array of numbers organized into rows and columns. Each number in this array is called an element. Matrices can represent data, transformations, and more across various fields.
So, what exactly is a matrix? A matrix is a rectangular array of numbers organized into rows and columns. Each number in this array is called an element. For example, a matrix can look like this. In this matrix, we have 2 rows and 3 columns. We can refer to the element in the first row and second column as M12 equals 2. A square matrix has the same number of rows and columns. For instance, this 3 by 3 matrix is square. In contrast, a rectangular matrix has a different number of rows and columns. Here's an example of a 2 by 4 matrix. Next, we have the zero matrix, where all elements are 0. It's often denoted as O. Here's an example. Finally, there's the 2 by 2 identity matrix, which has 1s on the diagonal and 0s elsewhere. It acts like the number 1 in multiplication.
In computer graphics, matrices are used to perform transformations like rotation and scaling. In engineering, they help in modeling systems of equations, and in data science, matrices are essential for organizing and analyzing data. To summarize, we learned that a matrix is a rectangular array of numbers, and we explored different types such as square, rectangular, zero, and identity matrices. We also touched on their real-world applications. Thank you for watching. If you found this video helpful, please give it a thumbs up and subscribe for more content on linear algebra. Stay tuned for our next video, where we'll dive into matrix operations.